All right, let's dive into something that's really changing the game in AI. We're talking about a framework called ReAct, and it's tackling one of the biggest, most frustrating problems with AI head-on. It's a super clever way to teach a machine how to reason, take action, and then actually learn from the results, making it smarter, way more reliable, and a whole lot less likely to just, well, make stuff up. So let's start with something you've probably run into. You ask an AI a question, and it gives you this beautifully written, incredibly confident answer that is just completely 100% wrong, right? This whole thing, what we call hallucination, has been one of the biggest headaches for large language models. But why does it even happen? Okay, so to get it, you gotta understand that before ReAct, AI development was kind of split down two separate roads. And the problem was each of those roads had a massive, critical flaw that made these kinds of mistakes pretty much inevitable. And this really lays out the core issue perfectly. On one side, you had what we can call pure reasoning models. Think of them as using a chain of thought approach. They're great at planning out complex problems step by step, but they're basically trapped inside their own head. They can't check facts out in the real world, so they often just invent them. Then, on the other side, you've got pure acting models. These guys can use tools like a search engine, but they act blindly with no real plan. You basically had a thinker who couldn't see and a doer who couldn't think. Not a great combo. So you can probably see where this is going, right? What if you could combine them? What if you could build an AI that could both think and act and use each skill to constantly check and improve the other? Well, that's the big idea behind the breakthrough we're about to unpack. And here it is, ReAct, which, you guessed it, stands for reasoning and acting. It's a framework that teaches a language model to weave its internal thoughts together with real-world actions. This creates this really powerful loop where the AI can reason about what it needs to do, take an action to find out, and then observe the result to update its own thinking. The process itself is actually pretty elegant and simple. First, the AI has a thought. You can think of it like an internal monologue. Okay, how am I going to figure this out? Then it takes an action, like actually searching the web. And finally, it gets an observation back, the result of that search. This new info feeds its next thought, and the loop just keeps going until it solves the problem. It's basically learning how to check its own work, which is huge. Now, I know that might sound a little bit abstract, so let's walk through a real-world example. You'll see exactly how this thought-action-observation loop creates an AI that's not just more powerful, but one you can actually trust. All right, here's our problem. It's a simple question for a person, right? But for an AI, it takes multiple steps. Find one cast list, find the other one, and then compare them. A pure reasoning model might just take a wild guess or hallucinate an answer. But let's see how ReAct handles it. So, step one is thought. Now notice this, the AI isn't just jumping to an answer, it's forming a clear, logical plan. This is like its own little internal strategy session before it does a single thing. Okay, plan in place. Now it executes the first part. The action is a concrete step. It's calling a tool, in this case, a search engine. The AI is literally reaching out into the real world to get the information it needs. And here's what it gets back, the observation. This is just raw data from the search. And this moment is absolutely critical because the AI now has external, factual information. It's not just relying on what it thinks it knows anymore. So, based on that observation, the AI has a new thought. It's not lost, it's not confused, it's just methodically ticking off the next step in its original plan. It's got the first piece of the puzzle, and now it knows it needs the second. And so, it takes the next logical action. Another search, this time for the second movie. You can really see that step-by-step, methodical nature of the ReAct process at work here. And boom, it gets its second observation. So now the AI has gathered all the external data it needs. Both cast lists are grounded in actual facts from its search tool. And now for the final internal step. With all the data collected, the AI does the last bit of reasoning. It compares the two lists and pinpoints the names that are on both. And there we have it, the final correct answer. By looping through thought, action, and observation, the AI got to a result that is totally verifiable. It didn't guess, it executed a plan using real-world data. And what's just as important is that the entire process is transparent. We can literally see its thinking every single step of the way, which, let me tell you, is a huge deal for trust and for debugging. Okay, so let's get into the nitty-gritty of this. Building a ReAct agent isn't just about setting up that loop. It's also about putting in some smart rules and guardrails to make sure the thing works reliably and, safely. I mean, what happens if the AI gets stuck, right? Searching for the same thing over and over. Or what if it tries to invent a tool that doesn't even exist? This is where you need those smart guardrails. For instance, developers will put a hard cap on the number of steps to stop any infinite loops. They also create a whitelist of approved safe tools, so the AI can't just try to run dangerous or made-up commands. It's all about building a robust system that can fail gracefully instead of just spiraling out of control. So for anyone out there thinking about building with ReAct, the big takeaways are really consistency and safety. You teach the AI the think, act, observe format by just giving it a few clear examples right in the prompt. You also want to keep those thought steps nice and short. It saves money and keeps the logic clean. And most importantly, you log everything. That full trace is absolutely invaluable for figuring out what went wrong and understanding exactly what the AI was thinking. Okay, so let's pull back from all the technical details for a second and look at the bigger picture here. Because this isn't just some clever programming trick. It's a major step toward AI that is truly grounded in reality. And that makes it useful in a huge range of real-world applications. And the potential here is just massive. Imagine a research assistant that doesn't just write a summary for you, but also gives you the exact sources it used to verify every single fact. Or a shopping bot that can check live inventory before it tells you an item is in stock. From customer support all the way to robotics, ReAct is making a whole new class of AI possible, one that can actually interact with our world reliably and transparently. So, to wrap this all up, ReAct isn't just another technique. It's teaching AI a fundamental human skill, the ability to stop, think, check the facts, and then move forward. It's building a bridge between the model's internal world and our external reality. And that really leaves us with a fascinating question to chew on. If an AI can learn to check its own work, what's the next human skill it's going to master?